Welcome. This is one of the problems from classical mechanics, and but you don't need to use that much mathematics. They are generally used in solving problems of classical mechanics, but this is one of the not the whole problem. It has been cut from a bigger problem. It is a small part of a bigger problem. And the statement of the question is just dumbbell of length L. Of course, its length. This is the dumbbell. Length L stands in a corner formed by a smooth flange. One is horizontal and another one is vertical. And the lower ball of the dumbbell is shifted horizontally by a very small distance to a very small distance. And the dumbbell begins to move. Okay, definitely there is no friction, so they will have no option other than to move. Find the speed of the lower ball at the moment when the upper ball breaks away from the vertical plane. So again there is a breaking off, and though it's looking already broken in the picture, but well, it's not already broken, it will break. इसको हल्का सा झटका दिया तो इधर ये राइट हैंड साइड में मूव करना शुरू कर देगा और ये नीचे आना शुरू हो जाएगा. तो आई थिंक थोड़ी देर बाद जो है ना कुछ ऐसा हो जाएगा, ये यहाँ आ जाएगा और ये कुछ यहाँ होगा. या and I would like to make this angle alpha so that at this moment this is moving in this direction and this ball is moving in this direction with velocity v. मतलब मैंने क्या किया है कि let the dumbbell form an angle alpha with the vertical. At the moment the upper ball is lifted off the vertical plane. अभी छोड़ेगा ये, and I let that the speed of the upper ball is v and the speed of the lower ball is u. And now we are going to use the law of conservation of mechanical energy. So I can write it here like it's their kinetic energies and the cost paid by potential energy. Their kinetic energies are half mv square plus half mu square. आई गेस्ट कि डम्बल के जो दोनों बेल्स होंगे, मतलब दोनों बॉल्स होंगे, उन दोनों के मासेस सेम ही होंगे. आई जस्ट गॉट इट. एंड डम्बल का सिर्फ एक बेल नीचे आया है, सेकंड वाला तो एक बॉल नीचे आया है, बाकी तो सब ऊपर ही था हमेशा. सो दिस हाइट आई नीड टू फाइंड दिस हाइट, एंड दिस हाइट total length was L. So total length was L. Okay, and this length is L cos alpha. That means this length is L minus L cos alpha. That is the height they have come down. So it is the cost paid in form of potential energy, and I'm going to write it: the cost, the gain, and the loss, 1 minus cos alpha. Yeah, that's right. And what can I find from here? We can find m and half things should be managed, and I would like to write this equation in form of this: b square plus u square, that must be equal to 2gl multiplied by 1 minus cos alpha. That should be it. And now what? I need a relationship between u and b. Since the rod is rigid, rod is rigid, so इस डायरेक्शन में, the component of velocity of this ball in this direction and component of velocity in the same direction, that means in this direction, that must be same. And this angle is alpha, this angle is 90 minus alpha, so this must be equal to 90 minus alpha. So the velocity of the ball in this direction is v cos alpha. In this direction, this is u cos 90 minus alpha, that is u sin alpha. So from the rigidity of the rod and the rod joining with both balls is of negligible mass, I forgot to mention, and I can write another equation. This was my equation number 1, I already got, and I just got a second equation, that is v cos alpha equal to u sin alpha. इससे पहले कि मैं भूल जाऊँ लिख देता हूँ. Yeah. So now 1 and 2 can be put together, and you got what? You got u square, that was needed perhaps. U square equals 2gl cos square alpha minus cos cube alpha. And before they got separated, the upper ball gets separated from the vertical wall or vertical plane, whatever it is. The center of mass of the dumbbell moved with a horizontal acceleration, and that horizontal acceleration was imparted by the normal force of the vertical wall. ये तो था. अब मतलब हॉरिजॉन्टल डायरेक्शन में एक्सेलरेशन था भाई, उसको डंबल के सेंटर ऑफ मास को तो होगा ही ना. डंबल पे तो फोर्स लग ही रहा ना, वेट लग रहा है, नॉर्मल लग रहा, नीचे से भी नॉर्मल एक लग रहा, ओह नीचे से भी नॉर्मल लग रहा है एक, और एक नॉर्मल तो इधर से लग ही रहा होगा ना, और साथ में फोर्स ऑफ ग्रेविटी दोनों का मिसिल, मतलब जिसका जिधर है नेट फोर्स ऑफ ग्रेविटी, इस टाइप से कुछ लग रहा होगा फोर्सेस भाई. दिस काइंड ऑफ फोर्सेस मस्ट बी एक्टिंग, और इस तरीके से लग रहे होंगे. आई वाज श्योर कि हॉरिजॉन्टल डायरेक्शन में तो एक्सेलरेशन होना ही होना है, वैसे तो वर्टिकल डायरेक्शन में भी हो रहा है. एंड देन वेल देयर इज एन एक्सेलरेशन इन वर्टिकल डायरेक्शन, but the horizontal direction में there is an unbalanced force, so there must be an acceleration. The center of mass of the dumbbell must have moved with a horizontal acceleration. And what about the moment of separation of the upper ball from the vertical wall? At the moment of separation, the velocity should be maximum. The velocity of the dumbbell should be maximum. So u should also be maximum. Velocity of the ball, the lower ball, should be maximum at the moment. तो क्योंकि सेंटर ऑफ मास को जो हॉरिजॉन्टल डायरेक्शन में वेलोसिटी होगी, दैट वेलोसिटी डायरेक्टली गोज टू द लोअर बॉल, बिकॉज अपर बॉल तो अभी तक he hasn't got its pi from the center of mass velocity, center of mass's velocity in vertical direction. So now it's breaking with the vertical wall. So in the horizontal direction, the velocity of center of mass is due to the velocity of the lower ball. Yeah, that's right. That's right. That means, and the force is now saying bye-bye. That means it is not going to act anymore because the upper ball is breaking away, so this normal is going to say bye-bye. So at this moment, this velocity is going to be maximum. That's right. So u or u square is given in terms of cos alpha. So To find the maximum value of u, we need to find out the maximum value of u square, and that means we need to find out the maximum value of cos square alpha minus cos cube alpha. Okay, I'm not going to find it. Rather, I am going to write, I have a function y that is in form of x square minus x cube. I just thought that cos alpha is equal to x and u square is y. So I'm going to find out dy by dx and put it equal to 0. This is 2x minus 3x square. And I am going to put it down equal to 0, and x is not equal to 0, cos alpha is not equal to 0. Definitely I can see that cos alpha is not equal to 90 degrees. Sorry, 0 is not there. 9 is not 90 degree. So I got x equals 2 upon 3. And that means cos alpha is equal to cos alpha. Yeah. That means cos alpha is equal to 2 by 3. So I'm going to put the value of this cos alpha into this equation. I'm going to get the value of u, and u will come out, what is the answer? Yeah, 2 by 3 under root 2 by 3 gl, and that should be the answer. This is the ready-made question, and I've solved it. Thank you very much for watching.